I am recording this session so that we can reference it in future, and indeed the group from Maria Lucia Okimoto's laboratory in Paraná will be able to use it as well online. So welcome to everyone.
Thank you.
This is a really exciting initiative for us here at Université UMoncton. I have been in contact with Alison Klein for the last couple of years, and with the Professor Maria Lucia Okimoto as well through that study group. And as we spoke, we realized that it would be an excellent opportunity to understand more of what the research is coming out of the laboratory there, the LABERG, if I am pronouncing it correctly, and you can correct me afterward, but specializing within engineering and design, and as well in ways that are relevant to our biomechanics courses here at Université UMoncton. So that's the brief introduction I want to give to people. Thank you very, very much, Maria Lucia, for organizing this, and I am looking forward to learning from each of your students there. We'll have Emilia, Christy, Isabella, and Alison after you have spoken to introduce us. And I understand there will be a bit of time for question and answer at the end. Am I correct?
Okay, yes. Thank you. Yes.
Perfect.
Okay. Now I will present the LABERG from Federal University of the Paraná. I am Professor Maria Lucia Okimoto from the Mechanical Engineer Department at Federal University of the Paraná. Here you can see some piece of my lab. But firstly, I would like to say I am very honored to be here with you, and I would very much like to thank Professor Nancy Black for this opportunity. The next information he stay here is about for my information about my career. I am product designer, a master in product engineer, and a doctorate in industrial engineer. In doctorate, I have done between Brazil and Germany. And I realized a postdoc in Technical University of München in Leite for ergonomics with Professor Klaus Blenger in Germany. And firstly, I would like to localize the Curitiba is stay in south of Brazil. And this state is Paraná. It's here. And we have several campus from very cities in the Paraná. The university is founded in 1912. And we have several informations about the numbers of the undergraduate courses and number of the graduate courses. We are the biggest budget of the state of Paraná and the biggest university in the Paraná and the 40 in the Brazil. Here I have some more pictures about the ergonomics labor. From left to right, here was in the pandemic, coronavirus pandemic, and I work in house and do some thing to help the people, to face shields and others, things for hospitals. And in the middle, we can see the discussion and the work with the students about product evaluation, usability, and ergonomic solutions. And the last, in the right, the students of the graduating course of the mechanical engineer work about scanning 3D. They help Isabella about your PhD program. Here I put someone about my interest topic is about inclusive design, usability, ergonomics, digital anthropometrics, and assistive technology. And in the last years, I have done projects about audio-tactile interface for accessibility for people with visual impairments and blind people. Other is inclusive design approaches of development of assistive technology. Body image capture of people with motor disability by low-cost 3D scanning, and ergonomics in production and utilization. And recently, I have approved in the an important project in the UFPR is about smart thing for assistive technology. And the assistive technology is starting 2014. It's about assistive technology research and development in engineering and design graduating programs. Here we have 5 universities interested about these issues, both mechanical engineering, production engineering, and design. And the results about this research was the PhD in mechanical engineering by Sandra March. She worked with tactile language for the identification of colors for blind and low vision persons. And the result was a patent on color coding system, the integration and concept of universal design and easily identifiable to be used in various ways. For example, package, object, or passed on labels, educational material in artwork, and others. Here you can see this didactical information about the C-color. This is the name of this código for blind, for colors. Start with the physical perception and the spatial position in the which I can put the color. In this position with the blind, with the braille, we can make this system. It's very easy to use, it's very easy to learn. Some examples of this application of the C-colors we can use in every material. For example, it's very little. You can put in everything with you need. And the other information about for the production by the C-color was made the master from Maria Lilian Barbosa from the Master of Science in Mechanical Engineer was about the embossing, that is a process, and encode process for stamp that can application in several materials, and the quality, the precision of this is C color. And the other project that was the research from Bruna Brogin about the method of creation of functional fashion for people with disability. She done this research. She won an award in Curitiba. And the other application was the digital anthropometric survey by 3D scanning for modeling plus-size fashion production. Kaellen Cheger is the Master in Science in Design. She found this is opportunity for fat women that have problem with the to wearing and to buy clothes, and it's very important. And now others people try to continue this research too. And the other was emotional response of human-computer interaction, a tool for collecting and analyzing physiological data using Arduino, for example, was Vitor Moreira. And now Vitor Moreira stay in PhD program in design too. Rodrigo Diego de Oliveira, Master of Science in Design, researched about accessibility and usability recommendations for web chatbots, inclusion of the blind user. And now Rodrigo stay too in the PhD program in design with me. The other information about research was done by Ana Helena Pérez Costa, Master of Science in Engineering, Mechanical, and she worked with wheelchair adaptations. And I have done a bidiplomation between Université Fédérale du Paraná and Technische Hochschule Ingolstadt in German about the program this and Fundação Araucária, and Lucas Cardoso Broto, that's the student in this mechanical engineer from the Master Science in Mechanical Engineer, development of a radar system for heat birth measurement of pilots. And I have students from the graduation program, and she have done the research about prostheses for inputs with Miss and distal phalanx, and with different materials from 3D impression about PLA with material, normal material, and conductive material. And the next is that you hearing here is about the research in progress in Labor, about Isabela Sierra, Emilia Sanches, and Alison Klein. I thank you so much for hearing me, and you can continue, please. Thank you. I will stay after to respond to some questions if you have.
Thank you very much, Maria Lucia. And Emilia, then it is to you.
Let me share here my screen. I hope everyone's seeing already.
Yes.
Yeah.
Okay. So hello, everyone. Good morning. Thank you, Nancy, for this opportunity. I'll be presenting a little bit of my research today, my PhD research, which is about an artifact to aid the design of 3D printed audio tactographics for blind students. My supervisors are both Maria Lucia Okimoto and Juliana Bueno. First, I'd like to acknowledge the entities that allowed me to do my PhD thesis, which is my university, the Federal University of Paraná, my graduate program, which is PPG Design, LABERG, which is my lab, and also CAPES, which is my funding agency. So a little background about myself before I start talking about my research itself. I'm a fourth-year PhD candidate from Brazil, and I'm on the line of research of information design, and I use inclusive design as a theme as well. My background is entirely on design. I have a bachelor in graphic and product design, and then after that, I specialized in graphic design on a small branch called information design, both on my master's and my PhD. Right now, I'm in Canada. I'm on OCAD and doing my doctoral stay at the Inclusive Design Research Center. We are doing a partnership where I'm doing part of my research here as well. So what is the object? The main object of my research is the 3D printed audio tactographic. And what it is exactly, it is could be a learning material for blind students that is accessible, it is inclusive to blind students, and essentially it is a tactile surface that is 3D printed that is augmented with audio descriptions or feedback. So it tackles both senses of auditory and tactile senses, and it is used to be equivalent to a visual learning material, for example. But it could be used for museums, it could be used for orientation, for blind students, for blind people as well. And why did I choose to the 3D printing rather than other types of audio tactographics? First, it can be open source, it can be shared, stored digitally, it can be decentralized, it can have a decentralized production, which is great for inclusive design and to be shared worldwide. It pairs well with the maker movement and also the inclusive design principles. And it has a liberty of geometric fabrication when you compare it to other types of learning material for the blind, which uses paper sometimes, which uses plastic, thermoformate materials. So 3D printing has a lot of liberty on that side. I'm bringing here some illustrations so you can see what I'm talking about. These are all 3D printed audio tactographics, and it usually paired with electronics, small electronics, such as Arduino on this one here with the artwork. Also NFC tags, Raspberry Pi or smart pens, smart rings, tablets, phones. So the tactile surface that is to the 3D printed, it is combined with small electronics, low-cost electronics that brings the sense of the auditory sense. So you have the audio side of that audio tactographic. So from my research scope, I want to tackle on is I'm building an artifact for educators, for designers, for makers on a sense that I want to help them with these artifacts to design this 3D printed audio tactographics that are accessible and inclusive for blind students. So I use my background as information design. I mix it up with inclusive design, accessibility, and education. And I'm building this artifact that contains recommendations on how to design this type of material. So how am I doing this? How am I building this content, this information, these recommendations to build my artifact? Is I'm using design science research, built and is shared with 4 phases. First is exploration, which is already done. I identified my problem. I did some interviews with the experts. I did some literature review. deep literature review, and I summarized everything in recommendations, in a set of recommendations from every guideline, from every requirement I could find on how to design 3D printed audio tachographics. And I grabbed these set of recommendations and I did a Delphi studies with experts to validate this information. After that, I entered phase 2 with proposition, which is almost done here at OCAD. And it is essentially the designing of that architecture on how this information will be presented visually for the makers, for the educators, for educators, for everyone that's interested in this information. So first, I organized this information, these recommendations on meaningful categories by doing a card sorting with experts, designers, with low vision students. And after that, I'm designing, which is in the final phase right now, is I'm designing visually how this artifact is going to be presented, which is right now is a web page inside our OCAD project, an ongoing project, which is a handbook for information for inclusive learning design. And after that, after this designing, I'll be evaluating this artifact with a design workshop, which with experts in the community, along with also visually impaired people, I'll be evaluating if this artifact is useful and how can I tweak a little bit to be even more useful. Phase 4 is just conclusions, where I'll be finishing my PhD, where I'm already publishing some work, some papers, some articles about it. So this is my final phase. So I'm just bringing here 2 screenshots because it's not yet online, but this is some preliminary results on how this artifact is being built visually. So every card is being transformed, every recommendation is being transformed into a card. So I'm presenting this in 3 categories, which is the results from the card sorting, previous card sorting, which is planning, materials and production, and context, use, and inclusion. So these 45 recommendations that were previously validated, they are being transformed visually to this webpage. So I'm bringing here our recommendation code, the recommendation itself, and some extra information. So this just another screenshot here that you can see how these recommendations are being built visually. So you have the recommendations, for example, involve visually impaired people and educators in the design and development phases. And then you can have some examples and some extra information below it. Some tips as well. And you can check how the project is doing right now, which is handbook.flowproject.org. It's not yet with my work inside it, but it's an ongoing OCAD and Inclusive Design Research Center project that you can check it out. But soon my work will be online as well, and you can check that out as well. Thank you for your time. If you have any questions, you want to talk more about it, you can reach me by email at emilia.ecps@gmail.com.
Thank you very much, Emilia. And my suggestion will be that we go through each of your presentations, and then at the end, that way we can field questions. And I suggest to those people attending, if you have questions or comments, you may put them already in the conversation. Si ce sont en français, I can translate into English if you so wish, so that's flexible. Isabella.
Hello, so I'll share my screen. Okay, I can bring you to the side here.
Transferiu a tela errada. Tá com a tela de digição.
Eu sei.
Ah, tá. Ah, tá.
Okay. So, hello, bonjour à tous. I am called Isabella, my name, and I'm also a PhD candidate here in UFPR. My background is really similar to Emilia, so it's kind of repeating myself, but I'm also a master in design, but my area is ergonomics and human factors. So I think it's a little similar for UMoncton, and I'm working with digital anthropometry of people with motor disabilities. I want to share with you a little bit of context before I explain my research. So I'm working with the intersection between these three themes. There are anthropometry, that is the basis of the research, motor disability, that is the public, and 3D scanning. Anthropometry and people with motor disability, there is always a little bit of problem there to collect, to measure people with disability. There is a lot of old and few studies that can be found, but they are incomplete, especially because of the popularization and the accessibilization of the 3D scanning. There is a technology that permits the collection of 3D information about the person that is being measured. And this intersection between 3D scanning and anthropometry is called digital anthropometry. And digital anthropometry for people with motor disabilities is the actual problem that needs to be fixed, because I've found there is a gap between the ability and the technology that we have right now and the necessities of the people with motor disability. So a little bit of explaining for those who don't know 3D scanning. Probably everybody knows, but I need to explain a little bit. So we have an object, and this object can be digitalized 3D-dimensionally to form a mesh, a 3D mesh that can be used to measure and actually to use it to develop projects and to use for ergonomic and product simulations digitally. So we have this ability to use collect the geometry of a person and then use this information digitally to develop products and to use the actual person in these studies, digital studies. And why do we use it for the anthropometry? Because information and 3D information is much more real than just bidimensional measures that we use normally in anthropometrics. So this is an example with a person with the same height, sitting height, but you can see that two people can be very different with the same sitting height. So what can we do if we have like this kind of information, this 3D information, especially for people that have different proportions and body capacities, and how can we use it? And there is actually a problem there. There is the requirements for the scanning. So 3D scanning requires that we can see the whole body of the person, so we can get the whole 3D-dimensionality of the mesh that is being collected. Normally, the position is this: standing up with arms separated from the body and etc., like this figure, like this image here. But like we said, people with motor disabilities have motor disabilities. They cannot stand straight like this to be scanned. And the results of this are meshes like this that I'm showing that have lots of holes and lots of problems that need to be fixed after the collection, after the scanning. But the problem is that we cannot fix it because we don't know the actual dimensions of the person. So we are guessing at the dimensions, and then we don't have a 3D model that is actually accurate to the person. So what are the associated problems with this question? One of the one that I'm just telling you about is the technology and methodology incompatibility. So we have technology, we have methodology, but they are developed and they are normalized for people that don't have divergent body composition. For these people, we need to have norms that help us to develop customized AT. We need to have to construct inclusive norms, and we actually need to do populational studies, We need to include these people in our population studies. But if we don't solve the problem of technology and methodology incompatibility, we cannot have these other problems. We cannot solve these other problems. So this is my research question. How can we do it? How can we collect digital anthropometry of people with disabilities, and especially with motor disabilities? Because they cannot stand in that position that we normalized. They cannot stay still for the time that we require to scan, but we need to do it because we need this 3D information to include them in studies, in population studies, and in the project development, and etc. So my solution, and I'm at the end of my PhD, so I have a little bit more of results. My solution was to develop a system that is called ADAPT, and this system has 3 parts. The first part is a protocol, is a process that helps with the act of including these people in the digital scanning and in the 3D digital anthropometry. Also, I've developed a product that helps and that enables this 3D scanning, and I cannot show you because it's being registered for intellectual property, so I cannot show you, but I'll be able to show you like next week. And I have also a software that helps with information management and registration of the acts, because one of the problems that I've discovered in studying digital anthropometry is the fact that we scan people and we have this 3D scan of the person, but we have no data about the act of scanning and the act of measuring, and then we don't have this process that needs to be included in the data so we can have a reliability and accessibility of this data. So the results are that we can, with my system, digitalize people with motor disabilities. This woman that I scanned, she doesn't have control below the bust, and we could scan her and have lots of 3D important and complete meshes that we could, and we did develop adapted AT for her specific needs. And also we could develop a 3D digital human model of her that can be used in many kinds of digital ergonomic studies that have her actual measurements and capacities and actual morphology of her body that can be used to realize these studies. And then we can include people with motor disabilities in our studies, our ergonomic digital studies, for inclusion of all people, and not only do these studies using normalized and perfect between aspas. And then that's the result of my study. Thank you. It's really fast, but my contact is here if you need to ask some questions. And thank you very much.
Thank you, Isabella. Indeed, we talk in the biomechanics course that I teach here at Université UMoncton about the fact that we tend to have tables which are a very small population, and we assume that that is the same, and you are going to another level of destroying those assumptions and allowing us to.
That's the idea. Yeah. Thank you very much.
Excellent. And now, Alison.
Okay, thank you. It's okay for you? Okay.
Very good.
Yes, okay. Hello, my name is Alison Klein. I am a physical therapist. I did a master's degree in mechanical engineering with Dr. Okimoto, and I am a doctoral student in design at the Federal University of Paraná in Brazil. All my colleagues também. In addition, I have been working for more than 20 years in ergonomic consulting in large and medium companies in Brazil. I'm very grateful for this invitation. Thank you, Dr. Nancy Black. As I am very thankful for the full support received from Dr. Maria Lucia Okimoto and my colleagues. Thank you. Now, I will be showing the artificial intelligence and computer vision for ergonomics analysis. In particular, I would like to introduce you to KineBot, a new technology to evaluate the ergonomics risks. Okay, I have a question for you. Do you really measure the reality in your ergonomics work analysis? Let's think about it. It's a big problem for me. I think it's a big problem for you too. In the ergonomics triangle of fire is the main model to observe in physical ergonomics work analysis. We observe the posture, no neutral positions, force, excessive weight, grip or pressure, frequency, lack or frequency, or too high of frequency. But I have a problem. How to evaluate these points, these facts? Let's go. We made research on the state of the art to usage of evaluating ergonomics tools and instruments based in scientific literature to understand the most used techniques and instruments. Then I listed the top 10 instruments more quoted, as you can see at this table. And after in this table, the top 10 looked as the Nordic is the first in the table, and the other top 10 in the world used in scientific literature. After that step, the question I showed in my mind was, why? Why are these tools is most used? I don't like all these tools, but I have the question because why these tools is most used? And these studies, I realized that these two tools were results of authors' proposals to simplify an ergonomics work analysis and try to measure any risk or exposition. That means to become measurable something that is not measurable. Another feature that caught my attention and that deserves to be highlighted in this presentation was the evaluation method, where predominantly indirect observation techniques. Look there. Interview, okay. Observational. Only 3 EMG kinematics and IMU or inertial movement units are direct, evaluate the real movement, but the others is 2 observational methods. Observe effects problem. Spending the observation of the main tools, we present some aspects to are mostly repeated, or they're mostly human dependent, do not evaluate complete cycles, do not allow full comparisons, long analysis times, analysis depend on the analyst experience, low reproducibility, kinematics works well in the lab, only in the lab. It becomes an inefficient cycle. According to Galileo Galilei, measure what can be measured and make measurable what cannot be measured. Let's go. Currently, we use, for example, a ruler sheet. Look there. A ruler sheet to evaluate our posture. But look there, the simulation presents different position and another results in each posture. If I evaluate this position, I have a score with ruler. If I evaluate this point, this moment, this instant, we have other another result, another result, another result, another result. If only in everything, anyway, we have another result if evaluate different points. Oh, so how to solve these problems? Observing the histories of ergonomics, kinesiology, the construction of assessment instruments and techniques, we noticed that researchers were always looking to solve these problems and sought within their limitations very creative solutions. In this slide, we can see a simulation with the kinematics. The research is in the past. Not that with single image, in the single image, we can find a lot of information that allows us to evaluate the biomechanics of the activity. Here, in this image, was a study. We did understand how to use the markers and what is the best measurement position. Not that bibliographic guides you to refer to anatomical points. Here, anatomical points, acromial anatomical points. But this anatomical point but this leads to measured error. In yellow, we have to measure it with the anatomical points. In red, the joint centers. Look at the difference and the center of the segment between with the anatomical points. Anatomical points is a very problem because the members have movement and the anatomical points turn around. We found that measuring joint centers allows us to better observe the position of the segments. Look there. This is a very good example of how difficult it is to evaluate a real scenario. Can you imagine a worker in this conditional? It's not possible to evaluate this form in the real life. Then we have conventional kinematics evaluation is rich in data, very difficult to apply in real situation, laborious instrumentation, and long processing and preparation time. Let's go. Artificial intelligence is better to resolve these problems. Let's explore the new horizon together. Artificial intelligence is already used in our daily lives, on our smartphone, in public control, in traffic control, and so many other applications. We have an artificial intelligence in many places, many forms. And how to use artificial intelligence in ergonomics, EAA, but plus artificial intelligence. The use of computer vision and the artificial intelligence to recognize movements and generate data has emerged with great success in the recent months. Here, I'd like to show you an example. Let's see how easy it is to use the KineBot. In only 3 steps, you will have the data on the postures and movements. Look at that, this other move. This move was made with my daughter. My daughter is a camera girl. Look at that. Oops. Okay, here. Up in this site. Here. In these webs, make a move of the worker. The duration doesn't matter, okay? And upload in the website KineBot. Upload here and press the report. You have three form of report. See the result. The first result is the video with the skeleton avatar. Is the very important to didactic form to explain about the posture and observation, the better or the wrong postures. It's very simple. In this report, we can see the left side ups and down here, show how intensive were the movements. In this case, showing the trunk. Here is the trunk, second per second, degree per degree. Clearly, the requirement trunk is activity. Look there at this moment, this posture is different this because the worker turn the right, bend your joint or not bend the posture. And the right side, we can see the frequency and duration of the movement in each wrist range. Here is the bend, and here the frequency is the duration of the time of the position of all the wrist. Neck, trunk, shoulder, elbow, wrist, hip, knee, and ankle evaluation results in a very simple and a practical way. Trunk, here, all the body. Here, let's see another way to see the evaluation. The percentage of time each joint was in each wrist range. Sorry. I think in the past, we used it to make a double way with observations. Here in the past. Then we moved to analysis with direct data. Use the equipment, tools, more technological, but currently we are able to use the artificial intelligence and computer vision to evaluate the ergonomic risk. Here, I think we are here. After this knowledge sharing, I want to invite you to build the future together. I think we need to think to build the future. Thanks for this organization. A special thanks for Professor Dr. Nancy Black and Dr. Okimoto, colleagues, and all the participants.
And thank you, Alison. This has been a wonderful wide breadth of learning of how design, how engineering can apply to making life better for various different environments. I'm very happy to open the floor to questions, comments. All of us should be able to activate your microphone, but I would suggest that you raise your hand first if you so wish, so that we can be direct about that. I have, perhaps just to get things going, a question for Emilia, because you were talking about this auditory tactile aspect of information design. And as I was thinking about it, I was thinking about in terms of the mechanical sides of design that you'd have to take into account size of sensors and things like that. Am I correct in that? Is that part of what you are doing?
You're absolutely right. There are some things, mechanical aspects that should be taken in consideration. Right now, I'm taking consideration more of pre-production aspects. So more of including that person that doesn't know much about accessibility, wants to learn about it, wants to enter this world and maybe turn their classroom a little bit more inclusive. So I'm not tackling exactly measurements or any mechanical little aspects per se, but this should be taken in consideration, of course. I did my master's on using 3D printing and tactile graphics as well, not using the audio sense, where I did take in consideration more these mechanical aspects, especially about 3D printing, and that turned into a model that could be used to build this 3D printed tactile graphics. And there I use a little bit more of product design and mechanical aspects, but not right now. I'm not taking into this. I'm not researching exactly into this, but this should be taken into consideration in the future as well.
And that will lead me to a question for Maria Lucia, which is, to what extent could your laboratory do collaborations with departments like ours in mechanical engineering, with students who maybe are doing the pure mechanics with your group?
Okay, in the lab, we can have students for different areas, design, mechanical, from health. We can see with Alison. I have supervised medicine, and every area that interesting in ergonomics and usability. And I'm point, for example, in Emilia, I introduced the cognitive ergonomics too when I observe the information, how the people with different needs observe and perception this information. And I think to work with different professionals is very distant and very right. I can learn a lot. It's very an experience very successful.
Could I make a comment as well? I think that everyone here and at the laboratory is working with accessibility or close to it. And accessibility is per se an interdisciplinary course or disciplinary area. So we need to have different professionals in the projects, because alone one person can do anything.
Mm-hmm.
And so one more information. When I studied solution for needs for the person with disability, for example, or blind, I need several professionals. We cannot have alone. We cannot complete the information. I need the several people together.
Mm-hmm. And Isabella, from your point of view, you were talking about the importance of creating standards for people who are different from the norm.
Yeah.
When, this is a trick question.
Oh my God.
It's a very small part of the population who have those mobility limitations. Why should we, as engineers, as future professionals, why is this important?
Okay, so first of all, it's not a small part, because number one, 7% of the population has motor disabilities. So 7%, it's a lot. And second of all, people that are aging, they have the same needs as the people that have motor disabilities. So if we include, and actually, if we use the system to scan people, aging people, it is actually better, because they also cannot do the same things. They cannot stand in the position for the same amount of time that we need. So the problem is that we need to think of these people as actually part of the population. They are a group and a big part of the population. And also, if we include these people that are different, we can include the people that are not. The problem with inclusion is that we normally separate these people, and then they are there and we are here, and then we cannot do anything because we just treat them as a part, a separated part. If we treat them as the same as the rest of the population, that's why I said that we need to do populational studies, not only of these people, but with these people, that they are included in the database. Because like the sitting height of people without disabilities and the sitting height of people with, they are different. And if we develop products that are adaptable for both of these heights, the product will be more useful for everybody. So I know that the trick question is, of course, they look like a small part of the population, but they look like it because we do not include them. So they stay at home, they do not participate. And if they would participate, and we would see that they are like a great big part of the population. Even more with the aging population that are, I don't know, but a lot of people that need the same adaptations. I don't know if I answered, but that's my answer.
Indeed, a very good answer. And in Canada, I don't know how it is in Brazil, but in Canada, we no longer have a required age for retirement. So anyone can work as long as they are physically and mentally able. They can work until whatever age. So in the past, our databases for the working population ended at 65. But that is no longer a valid assumption. And indeed, as you say, we can go.
Here we don't have an age to retire. Like we have an age that we can retire, but we don't have a maximum age that we need to retire. Mm-hmm. But the problem is also, it's not only work, it's pleasure, it's vacation, and it's tourism, and it's public spaces that we need to include everybody, not only in work, right? Also in other parts of their lives. Homes, kitchens.
Indeed, great. And I'm still keeping my eyes and ears open in case I don't want to always be asking all the questions, but I always have more questions, as my students know. Alison, so the magic of what you have created with Kinebot, going from a marker on the top to the center of, this is the holy grail, what people are always trying to say, how do I actually do this? So your system is able to take, tell me if I am incorrect, you are able to take a video wherever, and you can find the center of the articulation, the joint. Am I correct on that?
Thank you, Doctor. The Kinebot is a very simple to use. The simples. In the digitalizing image, we have esqueci como é que fala malha. Como é que é, Maria? Mesh. We have mesh, and we have a mesh of this segment. In the normal visually, we study, look there, observe the joint and the joint, X, Y, and Z point of this point in the normal kinesiology. But Kinebot not measure this. Kinebot visual system of the mesh of the segment, all the segment. If you localize the segment, we need to make the media point with point minus have a center of this point. Center here, we have 2 points. We have this segment direction. With this, this is different, is only possible with the intelligence artificial, because if you use the operator change the point, operator click the point, the operator wrong the position. We need a central or a mark or other thing. If you use the intelligence artificial, you point the medio, we have the segment, is possible to measure the angle.
Right.
It's simple, but complex. I and Dr. Okimoto studied a lot of it 12 years ago. No, 16 years ago, and we didn't make this because not possible. It's possible only in artificial intelligence here today.
And coming back indeed to the institution as a whole. Yes, Maria Lucia, you had something to say?
Yes, if the student made done some question, we can done with a French language. We can understand, and Isabella can translate it for us. Right, Isabella?
Yeah, I can. I speak a little bit French.
Excellent. Donc, on pourrait en recevoir en français ou en portugais, à la limite.
Oh, she said that they can ask in French or in Portuguese.
Going back to the institution as a whole and your experiences, because for my students in this class, this is an undergraduate course. I'll let Eve go forward, but then I have a question about general how people can study within your institution. Eve.
Oh, hi, can you guys hear me?
Yes.
All right, I had a question for Emilia. You mentioned that you would probably have to modify your system when it came to people with perhaps hearing disabilities. Have you looked into it? I'm interested to see what kind of modifications you're expecting from that.
Well, since the beginning of my PhD, I'm working with information and changing this information along with it. That's why I have many experts and many people with disabilities working on it, because I can't be the only person doing it and saying this is true, this is valid. So I'm bringing in the whole process people that has the expertise, and by expertise I mean a blind person is expert on their disability, so they are experts on this too. So they can say, oh, here, this is wrong, does not work on the real life when I'm doing a learning material or I'm building a learning material. So after I finish my PhD and I publish the results, or if I start a new project going further with this, maybe bringing some ergonomics aspects or maybe mechanical engineer process into it, I'm sure there's going to be stuff that I need to change, that I need to include. So that's my premise right there. This information is changing at every process, at every step. It's not finished when I finish my PhD. This is why why I'm making this information open source, because other people can work on it as well. So this is what I'm sharing with the world, and I'm expecting that changes will be made and will be beneficial to it. So I don't know if I answered your question, but I tried.
Well, thank you.
Thank you, Eve. Maria Lucia, at a general level, at the laboratory level, Lab Ergo, that you have there in Brazil, it's a very big program that you have. At Université de UMoncton, we're about 5,000 students, so a very small place, relative. What would you tell us to move forward in collaborations or in doing important work that will complement the kinds of things that your lab does in Brazil?
Okay. I think we can make the cooperation with others institution and university. I start here with make a seminar with about the theme, about the issues, and come people interested about that. When I start with research about with disability, it explodes with several people that try to make partnerships and relationships with us. Other institutions. Sorry, sometimes I think of in Germany, and it's not easy for me to speak fluently. I lived 2 years in Germany, and this is a confusing ergonomic things. Cognitive things is very hard. Okay, and I think this is some projects we can start together in little projects and to integrate students. We can integrate students in a classroom, in virtual classroom too. And I think it's very easy now. We can make it more efficiently information after the pandemic. Now we can more facility with these tools, the digital tools. And I think this is a way, it's very interesting for that. Now I coordinate a new project about this, the state government of Paraná too. I've been the coordinator of for several universities about the assistive technology. And we can, for example, introduce you for a palestra, a seminar to spoken about biomechanics in the process, for example. It's very important for us to evaluation the prostheses and the ortheses, for example. You have these aspects, and I think we can make together this expertise. For example, Alison, we can do this partnership in Canada to work with the KineBot for an evaluation in the biomechanics information together for this experience in the Canada. And we have now an open unfounding for the intercambio, I can say the
interinstitutional.
Yes. And it's in Brazil we have several opportunities to do this interchange for different countries. I think it's now. Yesterday I saw in the internet the 2 years ago the prorector from the university is established a partnership with University of UMoncton in the environment issues. It's very important know that this is more easy for others partnerships.
And indeed, Emilia, you are in Canada now, am I correct on that? So you are experiencing this kind of exchange.
Exactly. This is, as I said on my presentation, CAPES was my funding agency, and this is just one agency that enables students to go abroad and do this type of exchange. So it's a good opportunity to everyone to tackle on.
Isabella?
Yeah, I just wanted to clarify that I think Maria Lucia found that UMoncton and UFPR already have an actual partnership that is signed, and there is this bureaucracy is already done with. So it's really easy for us to go and for you to come because the partnership is already defined, decided. So I think this is what you found, right, Maria Lucia?
Yes. Another thing is CAPES, né? Has a program for change, né? The student from this is como que é? Intercâmbio, né? What can I interpretship?
Exchange period.
Yes, Emilia, for example, né? Stay by CAPES 6 months or more?
6 months, yeah.
6 months. Pay the como é a bolsa de estudo?
So scholarship.
Scholarship,
yeah.
And tickets, né? For the flight. It's very common here to send the students for exchange. In the PhD, it's normally to do this is sandwich. No? We can name it sandwich program. We stay one part of the students in the other country.
We just have 2 minutes left in our time for this meeting. I do not see any other questions from our side, but what I would like to have each of you do is just very briefly, then about 30 seconds, what things do you think someone who is going through mechanical engineering in Canada should take away from what you have told us today? So let's start with Alison.
Okay, thank you. Thank you for all. I think all the activities we evaluated until today can be re-evaluated. But now we have other thing to evaluate with more data. The difference in this study at the university and the applied in the industries need to be zero, to be diminutive. I think the moment to evaluate the situation in the industrial, the real life with the best knowledge to make better the real life the workers. Thank you.
Isabella.
Okay, so I think that we need to think of people as individuals and as people that have special and specific needs. Even us, we do have it. And also that technology can help us to integrate and to know better these people and not only to see data in a table. That's it. Thank you.
And I see there's a question that just came in from Gabriel Poulain, which is in Portuguese. So his question, if I understand his Portuguese correctly, I don't know if you can read it. Minha pergunta e para Isabella, você já trabalhou em exoskeleto? How's my Portuguese? Have you worked with exoskeletons?
It's good. Yeah, it's good. You have a good Portuguese. So yeah, I do not work with exoskeleton, but Maria Lucia has a student that do work with it, and he's in Germany now, right? Or he was in Germany?
No, he's in Brazil.
Oh, he's in Brazil. So yeah, and he works with it for the industrial workers to help with the load bearing of work, especially to the car industry.
In Renault, in Renault Fabric.
Excellent. Yeah. Emilia, your last words.
Well, I'd say that accessibility and inclusion is everyone's job. And just as designers, mechanical engineers are also solution makers. So if you bring a solution for one, you expand for many.
And Maria Lucia, last word to you.
Okay. I think it's very important this collaboration. We can have more information after if you need, and I think is the most important thing to do for the students. In Brazil, is the important word now is look for the people, look for the needs of the people, that you can find the good solutions for to life. Is for all people.
And on that wonderful note, thank you to all four of you for bringing your corner of Brazil, which is very far away physically, but thanks to pandemic, here we are with Zoom and we were able to bring people in. In fact, we have people attending from Université de UMoncton, also from the United States. I see people applauding. Again, thank you for opening up what I can provide in my classroom to a wider population. Colin, you had a quick question?
Yeah.
Okay. Thank you all. And if there are any more questions, I will stop the recording. But if there are any additional little questions, we can maybe have our guests continue a little bit longer.
Yes, of course.